Hi everybody, so welcome to our last video of Module 2, which is Module 2 Task 2.8, and our target for today is I can graph an exponential function given an equation, a table, or a situation in context. So we're going to be graphing exponential functions today. Now you'll notice that in this unit we spent a lot more time on linear functions than we did on exponential, and the reason is because, quite frankly, graphing linear functions is more complicated. Graphing exponential functions is something we're going to spend this task doing. So let's review how we've always graphed exponential functions before. This problem says, on the first day of school, there were 400 students who had not picked up their supplies from the bookstore. Each week, the number of students who had not picked up their supplies was cut in half. The starting value here would be 400. And in order to figure out the other values, I'm going to cut that number in half. So I would have 200, 100, 50, and 25. And again, I'm doing that by cutting it in half. Now, I know that this is an exponential function because the pattern is multiplication. And so let's start with some labels. If our inputs are weeks, we're going to have weeks here on the bottom. And if our outputs are students, we're going to have students here on the side. Now for my x-axis, I'm going to label this just 0, 1, 2, 3, 4. And for my y-axis, I'm going to choose to count by, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines here. So I'm going to go ahead and choose to count by 40. Or even 50, it doesn't really, let's count by 50. So 50, 100, 150, 200, 250, 300, 350, 400. Now I'm going to start by graphing my points. I've got 0, 400. I've got 1, 200, 2, 100, 3, 50, and 4 would be 25. You'll notice that those points make a nice curve, which makes sense. If this is an exponential function, it should be a curved graph. We need to decide whether to connect the dots or not here, and I'm going to say don't connect the dots, because if we're counting the number of students, we're not going to measure them with like a ruler. We're going to count them. And anytime we're counting something, we're going to be not connecting the dots. It's a discrete function. All right, now, what if I give you an equation instead? So to graph an exponential equation, it is a great idea to use a strategy of making a table of values. And that's what we're going to be practicing today. You're going to want to have a calculator with you today because I do think these problems are a lot easier if you have a calculator. Here's how we make a table of values. If we're given this equation, we're going to start by having x and y. Now, our starting value in our table can be found kind of how we find our starting value in a linear function. So I'm going to look at the x. Since it was not adjusted to get back to 0, I must have started with 0. And my starting value for my y would be the 2. And I know that because it's the beginning value. Now I'm going to use the pattern, which is multiply by 3. That's going to be my pattern. So if I multiply by 3, I get 6, 18, 54. You really only need 3 points in order to show that it's a curve. I like to have 4 because I do think it's even easier to see that it's a curve. And your x values are just going to count 1, 2, 3. Just go up by 1 each time. So now let's graph. So on my x-axis, I'm going to label 0, 1, 2, 3. On my y-axis, I'm going to count by, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So I'm going to count by 5s. I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Once I have that, I'm just going to have 0, 2, 1, 6, 2, 18, and then 3, 54. And you can see it's a nice curve. Once you've got that, you're going to go ahead and connect the dots. Just like when we're graphing an equation for a line, we always connect the dots. For an exponential function, we're going to connect the dots. An important thing to notice here is that the side of the function flattens out and it gets closer to the x-axis, but it doesn't touch. One thing I want to remind you is that this looks a lot like an airplane taking off, and airplanes don't hit the ground. And the reason that they don't hit the ground is because then everybody would be really hurt if your airplane hit the ground. So when you draw these graphs, you want to make sure that they get close to the x-axis but don't hit the ground. They just kind of brush against it. For the next problem, we're going to be graphing this equation. So again, my recommendation would just be make a table of values. Based on the equation, I can tell that my x is going to start with 0 because I did not need to adjust it to get back to 0. I can tell that my y is going to start with 20, and my pattern is going to be times 1/2. So if I multiply by 1/2, I get 10, and then 5, and then 2.5. And for my x values, I'm just going to go up by 1 each time. 0, 1, 2, 3. I'm going to label my x-axis 0, 1, 2, 3, and I'm going to label my y-axis. I'm going to go ahead and count by 2s. So I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So when I graph my points here, I'm going to have 0, 20, 1, 10, 2, 5, and 3, 2.5. You can see it's a nice curve. We're going to draw our exponential function. And once again, it's coming towards the ground, but you don't want it to hit the ground. So you want it to kind of come down and get flatter and just flatten out. For problem number 2, we're going to make a table because I do think that that's the easiest way to graph an exponential function. My starting x here is going to be 0 because the x did not get adjusted to get back to 0 at all. My starting y is going to be 4, and my pattern is going to be multiply by 2 each time. So I'm going to get 8, 16, 32. My x's are always going to be 1, 2, and 3. Now, if I label, I'm going to have 0, 1, 2, 3. And my y's, I'm going to count by 4s. So 4, 8, 12, 16, 20, 24, 28, 32. I'm going to have 0, 32. I'm sorry, 0, 4. Whoops. 1, 8, 2, 16, and then 3, 32. Bloop. That was wrong. I'm going to connect these with a nice smooth curve, kind of going up towards the sky. And when I go this way, I'm going to get closer to the ground, but don't crash. And then that's my graph. And finally, for problem number 3, I'm going to make my XY table because I do think that that's the easiest way to graph these. My starting x is going to be 0 because my x did not get adjusted to get back to 0, so it must have started at 0. My starting y is 27, and my pattern is going to be times 1/3. So 27 times 1/3 is 9, times 1/3 again is 3, times 1/3 again is 1, and my x's will be 1, 2, and 3. Now I'm going to label 0, 1, 2, 3, and my y's are going to be, I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27. So I'm going to graph 0, 27, 1, 9, 2, 3, and then 3, 1. I can see that curved shape that I'm looking for when I have an exponential function. This side goes up in the air, and this side is going to get closer to the ground, but don't hit the ground. That's it, guys. All you have to do here is make a table, and you should be able to graph these functions. Thank you guys so much for watching, and I will see you in class for some practice.